this lecture, we will explore cloud load balancing. Cloud load balancing provides scaling, high availability, and traffic management for internet-facing and private applications. You can distribute load-balanced compute resources in a single or multiple regions by putting them behind a single anycast IP address. Cloud load balancing is fully integrated with Cloud CDN, which is a content delivery network product, and together they can deliver content to users from the closest data center while processing up to 1 million queries per second. Traditional load balancers are physical devices that are deployed in an active standby fashion and need to be pre-warmed to handle spikes. The diagram on the left is a traditional one. The one on the right shows Google's solution, which uses maglevs in an active-active faction where they advertise all the virtual IP addresses of the load balancers to a peering router which equally distributes the flows. To ensure reliability, it uses connection tracking to keep track of backend devices and consistent hashing, which allows this process not to be dependent on specific maglevs. Load balancing has some features, like HTTPS load balancing. This can balance HTTP and HTTPS traffic across multiple backend instances across multiple regions. TCP SSL load balancing can spread TCP traffic over a pool of instances within a compute engine region. SSL offload enables you to centrally manage SSL certificates and decryption. Cloud Load Balancer also includes advanced support features such as IP version 6 global load balancing, WebSockets, and user-defined request headers. UDP load balancing allows UDP traffic over a pool of instances within Compute Engine region. Stackdriver logs all the load balancing requests sent to the load balancer. These logs can be used for debugging as well as analyzing user traffic. Seamless autoscaling helps your applications gracefully handle increase in traffic and reduce costs. Health checks ensure that new connections are only load balanced to healthy backends that are up and ready to receive them. Load balancing affinity provides the ability to direct and stick user traffic to specific backend server instances. And finally, Cloud CDN is integrated with load balancing to optimize application delivery for the users. So you can divide load balancers into these. You have global versus regional load balancing, external versus internal load balancing, and by the traffic type. Global load balancing is useful when users' instances are globally distributed and users need to access the same applications and content without delay. So in global, you have HTTPS, SSL, and TCP, and for regional, you have internal and network. Regional is used when users and instances are concentrated in one region and you only need IP version 4 termination. So traditional load balancers are regional. They have a virtual IP address for each region. A DNS balancer is used to route traffic from the internet to specific regions depending on the workload and location. Then a regional load balancer in each data center determines how traffic should be routed to the instances. So this has a lot of points of failure as well as opportunities for latency. Now, if one of the regions fails, then that information has to propagate and reroute the traffic in a manual way. In Google's solution, traffic is directed to a single anycast IP address and everything is in sync with the global control plane. The load balancing is done with something called Google front ends, and they sit at the edge of the network. These are distributed globally. Global load balancing supports HTTP, HTTPS, TCP, and SSL. Additionally, the service provides health checks, auto-scaling, connection draining, monitoring, and logging. So this is what a GFE looks like. You can notice that there are two tiers of network edges, and the data from the active to active maglevs is cached and synchronized across the global control plane. Google Regional Load Balancing is also implemented entirely in software. Instances are in a single GCP region, and traffic is distributed to instances within a single region. You can use the network TCP UDP load balancing to load balance external traffic, and use the internal TCP UDP load balancing to load balance internal traffic. This is what the regional load balancing looks like. It's very similar to the traditional system where you have regional VIPs with the usual benefits of being on the Google infrastructure. However, notice that the load balancers are on the edge of the regions. GCP's load balancers can be divided into external and internal load balancers. External balancers distribute traffic coming from the internet to your GCP network. Internal load balancers distribute traffic within your GCP network. The diagram here illustrates a common use case on how to use external and internal together. In the illustration, traffic from users in San Francisco, Iowa, and Singapore is directed to an external load balancer. This distributes traffic to different regions in the GCP network. An internal load balancer then distributes traffic between the US Central 1A and US Central 1B zones. You can use external load balancers when you need to distribute traffic from the internet to the GCP network. So the GCP external load balancing offers the following. HTTP, if you have HTTP or HTTPS traffic, then use the global HTTPS load balancing. If it's TCP traffic with SSL offload, then you'd use the global SSL proxy load balancing. If it's TCP traffic without SSL offload, use the global TCP load balancing. If it's UDP, then use a regional network load balancer. This can be for either IP4 or IP6 clients. Global or regional load balancing. Internal load balancing offers TCP and UDP traffic load balancing. The RFC 1918 is just a fancy way of saying private IP addresses. Here the client IP addresses are preserved, and health checks are done, and also auto-scaling without pre-warming, session affinity, and the regional load balancing. Then you have traffic type. The type of traffic you need your load balancer to handle is another factor in determining which load balancer to use. For HTTP and HTTPS traffic, you require global external load balancing. For TCP traffic that can be handled by global external load balancing, external regional load balancing, or the internal regional load balancing. For UDP traffic can be handled by the external or internal regional load balancing. This is the data model for the HTTPS load balancer. From the internet, the global Anycast VIP goes to a target proxy based on a forwarding rule. This target proxy could be HTTP, HTTPS, TCP, or SSL. This is also where you have the URL maps. URL maps map URLs to specific backend services. This can be a VM or a microservice. Then it goes to the backend services. Backend services can be managed instance groups or network endpoint groups. This is also where you can configure capacity and monitor for health checks. With SSL proxying for your SSL traffic, you can terminate SSL sessions at the load balancing layer, then forward the traffic to a virtual machine instance using SSL. SSL proxy can handle HTTPS, but this is not recommended. You should instead use the HTTPS load balancer. SSL proxy is a load balancing service that can be deployed globally. You can deploy your instances in multiple regions, and the load balancer automatically directs traffic to the closest region. For the best security, you should use end-to-end encryption for the SSL proxy deployment. Cloud TCP proxy load balancing is intended for non-HTTP traffic. You can terminate TCP sessions at the load balancing layer, then forward the traffic to your virtual machine instances using TCP or SSL. TCP proxy load balancing can be configured as a global load balancing service. With TCP proxy, traffic coming over a TCP connection is terminated at the load balancing layer. It's then proxied to the closest available instance group. Network load balancing distributes traffic among VM instances in the same region in a VPC network. The forwarding rules direct TCP and UDP traffic across regional backends. This traffic is unproxied original packets, and it does not load balance among instances. You can use network load balancing to load balance UDP, TCP, SSL traffic on ports that are not supported by the TCP proxy and SSL proxy load balancers. Google Managed SSL certificates are not available here. They're only available for HTTPS and SSL proxy load balancers. Google Cloud Platform internal TCP UDP load balancing distributes traffic among VM instances in the same region in a VPC network using a private internal IP address. Each internal TCP UDP load balancer supports either TCP or UDP traffic, but not both. The internal TCP UDP load balancer also uses a single backend service with an internal load balancing scheme, meaning that it balances traffic within GCP across your instances. You can't use this to balance traffic that originates from the internet. And this is regional, not global. Within a single region, the load balancer services all the zones. Network endpoint groups, also NEGs, are zonal resources that represent collections of IP addresses and port combinations for GCP resources within a single subnet. Each IP address and port combination is called a network endpoint. These are especially useful for Kubernetes. So the network endpoints can be set for Kubernetes containers, and a group of these can be set as a backend service to the target proxy when data is coming from the forwarding rule. These NEGs distribute traffic among microservices running in containers on your VMs. As you can see on the diagram here, this eliminates the IP tables, improves CPU utilization, and significantly reduces billable network traffic. The diagram on the left is a traditional, and the diagram on the right is the Google's network endpoint configuration. In this demo, we'll learn how to create an HTTP load balancer. In this demo, we'll learn how to create an HTTPS load balancer. Now we're back here in our familiar Google Cloud Platform dashboard. If this is your first demo, make sure billing is enabled and you're on the correct project. In this case, clicking down here, select a new project, or in my case, I'm selecting networking demo. Now for this demo, there's a document that explains the instructions and details, and you can find this in your lecture resources. This is a long demo and has several steps. So the demo here will be creating a load balancer which will direct traffic based on the content. So we'll be setting up URL paths, and depending on the type of content that the user is requesting, that's going to be forwarded to a different instance on the backend, which would be serving the content. So for this, there are several steps. So the architecture for this is that we'll have to create a few instances, and then we'll have to create the load balancer, and then set up some firewall rules, and so on. So the first step is to configure instances. So let's do that. Let's go to the navigation menu, Compute Engine, VM Instances, Create Instance. We'll call this www and US Central 1. Set the zone to 1B. And under Management, Security, Networking, and Sole Tenancy, let's click this. Let's go to the Networking tab, and let's populate the tag fields. Let's say allow HTTP traffic, and then let's set our network tag here to HTTP tag. And let's go to management now, and let's insert our startup script here under startup script. Let's go to our demo document, and we can copy our this, Control V, paste it here. What this is doing is it's installing the Apache web server, and it's setting the default SSL. So let's press create. Okay, that's done. Now let's create another instance. Create instance. Let's call this www-video, and we will leave it at the same region and zone as the previous one. Let's go down to Management, Security, Disks, Networking, and Sole Tenancy. Let's allow HTTP traffic. And let's set the networking network tag HTTP-tag, and let's go to management, startup script, and paste the same thing here as well. Then press create. And now our VM has been created. Now let's create a firewall rule. So let's go to the navigation menu, networking, VPC network, firewall rules. Let's create firewall rule, click on this. So let's enter the name, www-firewall, and we'll leave it as the default network because that's where our instances are. Targets, let's set specific target tags, and let's set our target tag that we chose before, HTTP-tag. Let's set our source IP filter to 0.0.0/0, and specified protocols, let's select TCP and port 80 and press create. Now let's create an external IP address. So let's go to the external IP addresses, click here, and then let's reserve a static external IP address. Click on reserve, and let's name this LB-IP1, and we'll set this to IP version 4 global, and click reserve. Now let's create an instance group for each traffic type. For that, let's go to Instance Groups, Navigation menu, Compute Engine, Instance Groups. Now let's create an instance group. Click Create, and then let's select Unmanaged Instance Group. We'll call it www resources, and set the region to 1 and the zone to 1B, and the network is default. And for VM instances, let's select www, and let's create. That's done. So now let's create another instance group for the videos. Press Create, New Unmanaged Instance Group, www-video as the name, region 1, zone 1B, network default, and VM instance www video. Let's create this. So now let's go create the load balancer. So let's go to Navigation menu, Networking, Networking Services, Load Balancing. So let's say Create Load Balancer, and we're going to choose HTTPS Load Balancing, so we can press Start Configuration, and let's name our load balancer. So we'll call this web-map. So now let's select backend configuration, select backend service, create backend service. So let's name this backend service to web-map-backend-service, and then we have protocol HTTP, backend type, instance groups, and backends, new backend, and then we can select the instance group that we just created, and let's select the resources, and then we can leave all the rest of the fields as default. Then let's create a health check, create health check, and we can name it health check-demo. Just leave the defaults and then create. Now let's create another backend configuration. So let's create and select backend, backend services, create backend service. So for this, let's select the name video service and protocol HTTP, instance groups, backends, new backend, instance group. Now let's choose the video, and we can select the same health check or create a new one. Let's create a health check, save and continue, and let's press create. Now let's configure the host and path rules. So let's click on this. So when we click on the host and path rules here, we can see that our backends are populated: the web map backend service and the video service. The first one is the default. So here we can see that the host sees any unmatched default, and the paths is any unmatched default as well, and this can't be changed. Now for the second backend, we can make changes here for the hosts and path. So let's specify the hosts here to the wildcard, which is your star, and then the paths, let's set it to /video and /video/star. So now let's configure the front end. So that's this part. Click on this. So for the name, let's type in HTTP content rule. We can leave it as HTTP now, and then IP version 4, IP address. Let's select our external static IP address that we created previously, and we'll leave it as port 80 because it's just HTTP. Click done, and we should be done here. And let's click on review and finalize, and this shows you a summary of all our settings. So here we can see that our backend service, web map backend service, and our video service, and then we can see the host and path rules, which are the star and /video/video/star. And then the front end goes to our external static IP address. This all looks fine, so we can press create. Okay, so our HTTP load balancer has been created. So now let's click on this to see the details. So here in our backend section, we can see if our backend instances, www video and www resources, if they're healthy or not. So here this should say 1.1, and that's when we know that things are working correctly. If it's 0.0, then it's still, the configuration is still happening in the background. So we can come back and refresh this and see if this has been set up or not. Now after a few minutes, after we refresh, we can see that both our backends are healthy. It says 1.1 and 1.1. So now we're ready to test this to see if we can get any traffic. So this is our front end IP address, which is the external static IP address. So let's copy this and right click, go to, and when it goes to the root, we get the www. So this is being served by the first instance group. So now if we click here and do video, hit enter, and now we see a different page, www-video. So this page is being served by the other instance group here, the second instance group, which is mapped to the path/video. So we can also check the monitoring here and see what traffic is coming to which backend. And here this is for all backends, and then we can select just the first backend or the second backend and see specifically how much traffic is coming. And also, since we enabled Cloud CDN, we can see the cache hits and other data as well. Additionally, we can also go to our Stackdriver monitoring and logging and see the data there. So let's go to Stackdriver, logging, logs viewer. So here if we select the cloud HTTP load balancer, we can either select all forwarding rules for this load balancer, or we can choose for a specific forwarding rule, which is the HTTP content rule that we created. And within that, we can even select specifically only for the web map or for all URL map name. So here we're going to select just for our HTTP load balancer that we created, which is web map, and for that forwarding rule, and then we can see specifically the data there here. So we can see the data is coming to the root and the data that's coming to the video. And then we can drill down and see the specific IP addresses and the instance groups and so on where the origin is.
For more details, check the link in the description. Learn with Whizlabs. Success certified.